Hello and welcome back. We are finishing off this course with our final topic during week 10 here, all about measuring team and project successes. We're going to talk a little bit about measuring our own successes for our project within our team and our own growth and success as an individual. Let's jump right in and talk about what success actually means in a software project. So, this might mean having a functional project, but it can mean other things too, like a happy team, getting your delivery out on time, coming in under budget. Maybe it's learning something new. It really depends what the point was for our software project. Let's talk a little bit about outside of a project that, we functionally can say was successful. Let's talk about our team's success. So let's discuss this idea of Tuckman stages of team development. This is really important, and maybe you didn't realize you were going through them with your team over the past 10 or so weeks, but you were. So the very first stage is forming. This is when we kind of form our team. It's when all of you got to know each other at the beginning of the term. You were kind of polite to each other. You were very cautious in maybe how you spoke to each other and deciding, oh, this is something I should or shouldn't say. And you were also trying to figure out your role within the team, right? So your strengths and your weaknesses and sort of how it compares to your teammates. Now, the second stage is the idea of storming, and this is when our conflicts really started to emerge, right? Everyone has different ideas and different working styles. You may have different beliefs on what should be prioritized, and this is when power struggles and frustration start to come out. This is when we test each other's boundaries. Things may or may not get done, and it takes some time to sort of push through this stage. The third stage is norming, and this is probably your iteration 2, maybe the start of your iteration 3. Norming is when we all have a good understanding within our team of the roles and the processes that we need to follow and sort of the roles within our team, right? Like this is the norms that we want to sort of establish. And these begin to settle. We have a little bit more trust in each other. There's more cooperation within our team. And the conflicts that we may be having, we now know how to actually interact with each other. The conflicts get better and we can sort of be more constructive. The last stage in Tuckman's stages of team development is performing. And this is where you hope to eventually get. And in a group project, we hopefully have some of us who have reached performing in the real world. This is where we end up, which is that we have a high trust and autonomy with each other. Our team knows how to focus on goals. We can adapt quickly and we can start to deliver results. If you take 4350, we get to performing pretty quickly in our team groups, and you have this opportunity to really start soaring through, getting your features and your work done, because you can all kind of trust on each other to get things moving and get it completed in a reasonable amount of time and with like a reasonable amount of quality. Like you kind of trust each other's quality a little bit more. So how do we actually measure our, productivity and how we're moving through these different stages? And sometimes it's really obvious if we're fighting and frustrated or we're not. But sometimes, we might want to be able to sort of rely on more quantitative tools as a way to sort of measure and assess our team's ability to perform. So let's start by discussing burndown charts. Burndown charts are effectively a graph that will show us the work remaining versus how much time is left. So it's a visual way for us to track our progress against our plan, right? So at the beginning of your iteration, you would have made a plan based on, our estimated hours or story points or whatever it was. And then as time goes on, you were hopefully logging your time against your tickets and closing tickets as they finished. And we can visually track this as well. This allows us to do things like spot scope creep. Did we add a bunch of tickets halfway through our sprint? Did we have a really big slowdown in the middle of our sprint because, there was a term test in another course? And we can track, of course, early completions. Are we constantly coming in under, estimating and stuff like that? So if you're ever given a burn down chart to look at, to read, once you generate your own, I should say, our x-axis, so our horizontal axis, that's going to be basically the number of days in our sprint. If we had 13 working days, 20 working days, it just depends, right? This may vary as well depending on the sprint. If there was like a stat holiday and nobody worked, or if you're doing it on an individual level and you had only allocated X number of days to be actually working days, right? So it's not quite so simple as saying, oh, 3 weeks, 21 days. We can get an approximate that way, but we might want to do better. And then our y-axis is the remaining work. So at the start of the sprint, it's all remaining work because we haven't started our sprint yet. And then as time goes on, hopefully we see that number started to decrease, right, and head downward. Now, ideally, what we see is like this really nice, smooth diagonal line that shows us consistently working toward our goal until we reach the end of our sprint and we zero out our work. But in reality, that is hardly ever the case, right? In reality, this line is going to be jagged. We will have done some work and then we'll take a step down and then we'll have done some work and take a step down. It usually looks like more like a stairs. And hopefully we're not seeing very much of this, going up situation, but this step pattern is very common. So when we're actually looking at it, how do we like interpret this? If we find ourselves constantly above ideal. So if you were to take what you would hope ideal looks like, again, it's that diagonal line, and we find ourselves constantly above what the ideal should be, constantly, consistently, our line, our bar is above the ideal line. Well, we're behind schedule. Maybe we have blocked tasks. Maybe we've been underestimating complexity. We need to sit down and really look at why is it that we're coming out behind every single day, every single sprint, whatever it might be. Depends if you look at a bunch of these all together or we're just looking at, one sprint's data. If we're constantly below the ideal looks like this, and we're constantly finding ourselves falling below the ideal in that image. So then maybe we add work and we fall below, and we add work and we fall below, and we're always sort of coming in under what we expected. We're ahead of schedule, right? We're getting more work done than we expected. Now, this might be that tasks are smaller than were expected, but it could also mean things like the scope of the project reduced. Maybe we put stuff into the sprint that later the business team said, oh, we don't actually need that anymore. And it just gets thrown out. And so now we are coming in under what we expected. And of course, if we see a flat line, that means no progress, right? There could be a potential blocker, maybe some dependencies that aren't resolved yet. That's not going to be great either. So it's really important that we sort of know what our ideal should look like, which is that diagonal, and then understand what it might mean if we're not following that diagonal. This can be interpreted in a different type of chart as well. So the burn down chart was very specific for the number of days and the amount of work. And this one instead is a little bit, and our line was going down, right? Here we see a velocity chart. We see a line going up. This is different. This one is going to show the team output per iteration. So each iteration, we can see the story points or the number of tasks completed. Depends on how you want to measure it, right? These are really useful for forecasting how much we might be able to do in a future sprint. So in the beginning, this may not be that helpful of a metric, but over time, when you work with your team, you hopefully will eventually plateau, honestly. You'll reach a point where you're in peak performance and you can see that your team is doing a great job of sort of saying this is how much work we can get done, and then we actually did it. We actually do it. And those numbers sort of flatten out, right? So this isn't great for like a single iteration. This is more of like an overtime visualizer that can help us. So again, maybe the x-axis here should be like over multiple sprints, and then the y-axis here is the number of tasks, points, hours, whatever it might be that you are using to measure. And what we want to see is a steady velocity. That means that we have stable process, our estimations were on track, and we were getting it all done as we expected. It allows us to use it as a confident predictor in the future. If we instead see a constant increasing velocity, that's not a bad thing. That could mean improving productivity, or maybe our scope is changing. But at some point over time, you want to see a steady velocity, right? And then, of course, if we see a dropping velocity, there's lots of different reasons for that as well. Potential blockers that came up, bigger stories that just required more time, so that's why there's fewer of them. capacity changes. So like maybe people left your team, people quit, people were fired, who knows. So now we just can't take on as much. Again, this chart isn't so much a be all and end all, or we're doing a great job, we're doing a terrible job. It's an indicator that should help us plan for the future. So some pretty common pitfalls are sort of allowing ourselves to inflate the number of points that are associated with a given task within a sprint, right? So over time, if the same work gets assigned more points, we can make our velocity as a team look higher, but not actually be doing better as a team. Also, a very common pitfall, like I said, was like if some sprints just happened to be overloaded and others were light, or some sprints had 10 people working on it and some had 7 people working on it. Effectively, this idea of a common pitfall comes down to one point, which is over-reliance on these charts. These charts are not a be-all and end-all. They do not explain everything about a team. They are one facet, one perspective into why things might be going the way that they are, and they are one piece of the puzzle when we're trying to make educated guesses and estimations for the future. Things that really tell you that you're doing well, right? So some green flags for things are going well. Because we can fudge these numbers, right? We can accidentally inflate or purposefully inflate our points that make it look like we're doing great. But that's not really that helpful of a metric. Some actual very real green flags that we should be paying attention to, that we should be patting ourselves on the back for. Regular commits. Steady incremental progress is always a green flag. Code reviews. If you're actually doing code reviews, you're doing a great job. Visible progress, right? If we're actually showing features that are working in our development on odd-word environments. Team learning. Are you all sort of knowledge sharing? Can you work on a part of a new part of your project each iteration? Does that knowledge transfer happen? Are you documenting and improving your processes? These are green flags. Things are going well. And of course, healthy communication. When things go wrong, we talk about it early. We're documenting our decisions. How many of these things could you put a check mark beside right now and say you've been doing well? My guess is probably visible progress, and there might be a little bit of team learning. And Lord, I hope for the other 3, but I know that those often fall behind. Now, signs that we're not doing so well. If we're repeatedly missing our planned goals, so missing sprints, that's probably a pretty big warning sign. Unclear ownership. Nobody knows who's responsible for a task or an area. Everybody in your team should be able to at least go into Git and see who's responsible for what. The blame game there. So if your instructor comes in and says, well, who worked on this? And you're all shifting blame onto each other. No testing or no continuous integration. You won't have continuous integration in these projects, but like in the future, if you have large pieces of code that are just completely untested, that's a red flag. Long periods of silence, both in your project, like in the commit logs, but also within whatever communication style you're using, a group chat, Discord, a Slack channel, email, whatever it might be. If there's long periods of silence, that's a problem. That means we're not keeping up with each other. And lastly, as we all know, last minute crunches. If there are repeated sort of instances of individuals trying to like save the delivery before the deadline, that's a warning sign that we're not doing a good job of planning. So now I want you to take a moment to pause and reflect. I would like you to go and calculate your own project's burn down for the last few iterations, as well as your team velocity, and actually sit down and critically analyze it. Is it what you're expecting? Does it surprise you? How could you plan for the future? What can we take away from this about our own team dynamic and what we might want to do should we, take on software engineering too, or go into the workforce and work on a team? You can also take a look right here at the following sample team velocity chart right here. So I've got an initial scope, a final scope, and what actually finished getting finished in the project. So this is day 1, what they planned. This is at the end, what they ended up saying that they were going to do. So maybe some scope creep occurred or maybe things, dropped off. Hopefully these are pretty darn close to being equal to each other. And then this is what actually got finished. And then this is just going to be an average across all the data points. taking a look at this, what trends do you see? And what can you say about the team that this is supposed to be representative of? So I'm not going to give you any hints. I think you should take a moment and do it and then discuss it with your group. Discuss it in class even, right? Get multiple groups together. You're all watching the same video and see if you can start to glean some insight into maybe what this group should do for their next iteration. You'll also notice that, what is this here? Part 1, iteration 2, iteration 3, iteration 4, iteration 5, iteration 1 over here. Oh, this is for a second grouping. That's why. Yeah, I'm like looking at this, like, what the heck am I looking at? So we can see that these are all associated with one group, and then this is the start of a second group moving on with their next iteration. So you can take a look at this. You can read through the link that's down here as well. If you click on that link, you'll be able to go and see where this came from and sort of get a better understanding of how this velocity chart specifically was sort of created and what it's supposed to be representative of. That's all there is to this topic. So thanks so much for tuning in, and I'll see you all in the next video. Bye.